Well, welcome back. This is lesson 7.3 on proving triangles similar. And this will be very, no pun intended, but this will be similar to what we did with our triangle congruence theorems. But this time we will have similarity theorems. So our first postulate is the angle-angle similarity postulate. And this one says that if we have two angles that are congruent in two triangles, then the triangles are similar. So we don't need any sides, just angle, angle. So that's a new postulate for us, or a new theorem. So using that postulate, can we prove that these two triangles are similar? Well, in triangle RSW, we have an angle that's 45, and in triangle VSB, we have an angle that's 45. So we already know one of those angles are congruent. So we only need one more set of angles to be congruent, and then they will be similar. And we actually have the vertical angles are always congruent. So we know this angle here would be congruent to this angle because those are vertical angles. So the two triangles are similar by the angle-angle similarity postulate. What about the ones below? In this one we have a 30 and a 70. In this one we have a 70 and an 85. Well, it turns out that angle L and angle R are congruent. That's obvious. But we have an 85-degree angle here and a 25 down here, and this one's 80 for angle K. So these are not similar because we don't have two angles that are congruent. Here's a couple for you to excuse me, for you to try. Go ahead and pause the video, and I'll give you the answers when you come back. All right, on letter A here, let's start off with this one. And we know that this angle down here is 51. If we add 39 and 90 and subtract from 180, we get 51 is left. And the same thing over here, 39 is left. So we actually have all of the angles congruent there. So this one is definitely similar by the angle-angle similarity postulate or theorem. Over on the right-hand side, if this one is 68 and it's isosceles, we know the base angle is also 68, which leaves 44 for the top vertex angle. But in the triangle on the right, that's not the case. We have the vertex angle is 62. It is also isosceles, but the base angles are 59. So that one, we do not know that those are similar, so that is not similar triangles. All right, so two more of your theorems for you. There's side-angle-side similarity theorem and side-side-side similarity theorem. And they're just like we had before. If we have the sides being proportional rather than congruent and the angle between them, then they're similar by the side-angle-side similarity theorem. And if we have all three sides being similar or proportional, then they are similar triangles by side-side-side similarity theorem. So let's check out some problems using those theorems. So it says, are the triangles similar? If so, write a similarity statement. So first we want to set up our ratios, and we'll just go shortest side, longest side, and remaining sides. So in this one, if we're going to compare the shortest sides, we're going to compare 6 to 9, which reduces to 2 to 3. The longest sides would be 8 and 12, the hypotenuse, 10 and 15, which is also a ratio of 2 to 3. And then the remaining side is 8 and 12, which also reduces to 2 to 3. So therefore, those are similar triangles by side, side, side. What about these two triangles that we have one embedded in the other? Well, we know that angle K is congruent to itself. Okay, if we draw them separately, they share angle K. And then we can start comparing some sides. Well, we can look at the length of KL and compare it to KM. And KL is 8, KM is 10, which gives us a ratio of 4 to 5. KP is 12, KN is 15, which is also a ratio of 4 to 5. So what we have here is we have two sides that are proportional with an angle between them. So those are definitely similar by side angle side. How about these two? Give these two a try. You know what to do. I'll give you the answers when you come back. All right, hope you gave those a try. For the first one here, letter A, okay, we're going to compare AC to EG, BC to FG, and then AB to EF. And when we put the numbers in there, we get ratio of 6 to 8, 6 to 8, and 9 to 12. They all reduce to 3 to 4. So therefore, in this example, those definitely are similar by side, side, side. Over on letter B on the right-hand side, we're going to compare the ratio of AL to AC and AW to AE. And we also know they share side, or angle A is common. So these two are in the ratio of 1 to 2, and we do have an angle between them. So those are definitely similar by side angle side. All right, here's a proof. We want to prove that these two triangles are similar, and we're given that FG and GH are congruent, and JK and KL are congruent, and angle F and angle J are congruent. So our first statement, these are givens, would be our reason. So both triangles are isosceles by definition of what was given. Angle F is congruent to angle H and angle J congruent to L. Angle F is congruent to H because of being an isosceles triangle, and the base angles are congruent in isosceles triangles. So F is congruent to H. L is also congruent to J. But these two are congruent. They were given. So why would H and J be congruent? Well, that's the transitive property. So H is congruent to L, also by the transitive property. So the triangles are similar by the angle-angle postulate. Here is your lesson check. Please work on these 3 problems. See if you can solve those and bring your answers to class. See you next time.